abandon that asset and you can replace that asset. Okay, so first situation is where you are replacing the asset. It can be an asset or it can be a component. Sometimes if you take the bigger equipments, bigger assets like aircraft. Okay, so aircraft is composed of many parts. Okay, so different parts will have different lives. Okay, so sometimes um, failure of a single part might lead to the failure of the entire asset. Okay, altogether. Okay, so we had a old black color television, like it was not of the flat screen, the regular one, the before we used to get those models. Okay, we the brand of it was Thompson. Yes. So always it was going for repair. We used to call, so there was something wrong with the television set. We used to call the mechanic, okay, to repair that. Okay, and we used to get the mechanics for this particular brand. Very few were there. Okay, one or two were there. So we had the phone number of one, so we used to call him. Okay, so he used to repair. So that was quite an old television set, 20 years old. Okay, so I used to ask him one question every time when he used to come for repair, that when do you say that asset is fully, like I have to fully replace the television set with a new set? Okay, so he used to say that as far as picture tube is good, you can continue with the television set. Okay, so picture tube, he said, was a very important component for that asset to work. Okay, so so there are few components, few parts of the bigger asset which are very important. Okay, so failure of which we have to replace the entire asset. Otherwise, in a bigger asset where the different parts, it's not necessary that all the parts will fail at the same time. So you have a particular asset in which different parts are of different lives. Okay, different lifetimes. Okay, or they have bought at different times. Okay, so life of the one part might be, it is 1 year old, one part can be 5 years old. It can be. Okay, based on the failure of the component, we tend to replace that very component. Okay, so first one, if you have the material with you or the PDF of the material, you can go to 103 page, or I'll be sharing that soon. Okay, it talks about the replacement of the items that deteriorate, depreciate. Okay, depreciate. Okay, so when the asset depreciates, what happens is there are basically two costs which are involved in an asset. Okay, one cost is the capital cost. I'll be sharing the whiteboard, please. Yes. Yeah. Is my whiteboard visible? Is it visible, please? Someone
Yes.
can come. Yes. Okay. So here there are two costs which are involved in using the asset. One is the capital cost, like I need to buy the asset, isn't it? Suppose I have to use that television set, I have to buy the television set. I have to use a particular machinery, I have to buy the machine. So for that I spend some money, right? That is known as capital cost. Then the other cost is to maintain that. To use the machine, I incur some cost. Okay, because of the using of the machine, what happens is it gets worn, torn, wear and tear can happen, or the machine can meet with an accident. Okay, because of maybe the person didn't know how to use it properly, it meets with an accident. Okay, because of which it depreciates. Okay, so what happens is here usually we charge depreciation every year. Okay, every year we charge depreciation, but the maintenance cost, so depreciation is the part of the capital cost which is charged every year. Like suppose the logic here is maybe I am not sure whether you had accounts in your syllabus or not, but suppose I have spent 1 lakh rupees to buy a machine. Okay, 1 lakh rupees to buy a machine. So entire cost 1 lakh, I need not show it in a single year. Why? Because this machine has an economic life. Suppose the economic life of the machine is 5 years, means I'm going to earn revenue because of this machine for 5 long years. So how can I charge the entire cost in 1 year? It is quite unreasonable for me to do so. Okay, so what I do is I divide this cost into some equal components or unequal components depending on the logic. Okay, and I charge it every year and I show it as depreciation. So depreciation uh, is what is shown. It is the part of the capital cost which is divided amongst the years. Okay, apart from that, we need to spend on repairs and maintenance also. Okay, so that repairs and maintenance usually will go on increase as the asset gets older, because in the initial periods maybe you spend less on repairs and maintenance, but as the years pass by, as the machine gets older and older, the cost gets increased. Okay, so these are the different things about the um, depreciation. So we have to take a decision as to we have to replace the machine which has depreciated or not. So simple logic is here, when do you decide whether you have to replace the machine or not? Suppose I'm spending too much on maintaining the machine. Okay, too much on repairs. Okay, so it's better for me to buy a new machine. Okay, suppose I'm spending 80,000 rupees for on repairs every year. Okay, so there is no point carrying on with the same machine. Okay, it is giving me trouble and I'm not able to continue my production hassle free. So what I do is it's economical for me to buy a machine. Okay, for 1 lakh, a new machine for 1 lakh. So this is where I take the decision, like if the maintenance costs are more, or maybe it is economical for me to buy a new machine rather than continuing in the old machine, I take a decision that I'm going to replace the machine. So replacement decision I take, I do thorough cost benefit analysis. What is the cost I'm incurring if I'm continuing with the old machine? So see, 80,000 is what I'm spending on repairs every year. And above that, this machine is not working properly, because of which my production, I have to bear some other costs, which are the implied costs, okay, which are not seen also, because the machine is not working properly. There is a break in my production cycle, and there is a break in my demand cycle. So what am I'm losing an opportunity, I'm losing a customer because of this. So what I do, it's better for me to buy a machine rather than continuing with the old machine. So I take a replacement decision of the machine which is deteriorated, okay, which is depreciated enough. Okay, so this is the first thing. Okay, then uh, second decision, which in the next page only it is given, page number 104, that replacement. Are you all having the PDF? Are you all having the material, right?
Yes, yes.
You are given the soft copy or hard copy by the
Soft copy.
soft copy. Okay. So I suggest maybe you can take the print and you can read from the hard copy rather than going spoiling your eyes. Okay. Uh, so here the next decision is replacement of items that fail completely. Okay. When there is a failure of the machine, how would you take the replacement decision? So here we have two cases here. Okay. One is, are they going to replace the individual component which is broken, or individual piece which is broken or which is failed, or are we going for the group replacement policy? Okay, sometimes we have a certain I don't call it as an asset, but maybe this asset which is of very lesser amount. Okay, the cost is less, but we have too many things. Say we have light bulbs. Here he has given the example of the light bulbs, which the numerical will be solving it. I hope everybody, the two students, whoever are there present, are carrying their book and pen calculator with them. Yes, I'm sure you
Yes,
people have. Yeah, yeah. Okay, I'll be sharing the numerical with you all, the PDF of the numerical. If you have it in your system, you can also go through that. Okay. So here we have something known as mortality theorem. Okay, when mortality is to do with the death. Okay, so they compare with the death of human beings with the death of the machine. Okay, so you have something known as birth rate, you have known as death rate. So death, he has compared it with the failure of the machine, and birth, he has compared it with the replacement. So suppose some bulbs fail. What do? We immediately remove those bulbs and replace it with the new ones. Okay. So suppose we are using say 1,000 bulbs. That is what is mentioned in the example, the numerical which is given, followed following the mortality theorem. Okay. So suppose he has given an instance like there are 1,000 bulbs, okay, in your entire organization. 1,000 bulbs are there. Okay, their bulbs are of lesser value only. The cost is not that much, right? Suppose few of the bulbs fail. So is it beneficial for you to replace only those bulbs, or is it beneficial for you to replace all the bulbs irrespective of their lives? Okay, their lifespans. Okay, some bulb can last because it can be a design defect, it can be the manufacturing defect, whatever it is. Okay, so uh, though they are manufactured in the same unit, but then they tend to have the different lives. Okay, they tend to have the different lifespans. Okay, so is it beneficial for individual replacement or group replacement? That is what we have to solve in that numerical. Okay, so I'll be sharing the screen with you. I have already shared it. I will move on to the material which was there with you all. 1 minute. Here there are some printing mistakes. I uh, think you should take a note of it. Maybe those are typing mistakes. Okay, so there are some mistakes in this numerical which was discussed in this page number 105 and 106. It starts on 105 and ends on 106. We'll be doing it together. Yeah, see here. Before we were talking about the replacement of the items that deteriorate or which depreciate. Okay, then he is talking about the thing where replacement of the items that fail completely. Okay, so here we have two instances where we are individually replacing only the item which is failed, or are we going to replace the whole lot instead of only replacing the few which have failed. Rather than that, are we replacing all the items which are failed and items which have not failed also? Okay, so how does it work out? So here he has given you the assumptions of this theory, and he has compared, as we have discussed before also, he has compared that with the death of the human being. Mortality tables are there. Okay, so usually the insurance person, it is altogether different science, that is actuarial science. Okay, actuarial science talks about, like, if you must have met, I believe everybody must have taken the insurance policy. Okay, he carries a table of probabilities where based on the age, the immediately the premium changes. Okay, so they have, suppose a person is, I'm 47 years old. Okay, so for my age, and for the ailments, suppose I'm a diabetic, I'm not, but then suppose I'm diabetic, and suppose I have hypertension also. So what should be the premium which should be collected? Higher the risk, higher the return. Okay, for insurance policy, they are taking the risk which is borne by me. Okay, by insurance, it is the risk transfer. So he'll be carrying the probability, mortality tables he'll be carrying. Okay, the actuarial science, he has the probability values. Like, how much would be my expected lifetime? So based on that, my premium will be decided. Okay, otherwise, suppose if my lifespan is less and the premium charge is less, so it is a loss for the insurance company. So they'll be charging very less premium from me. But when suppose God forbidden something happens to me, they have to pay a hefty amount. That's a loss for the insurance company. So they have something known as mortality tables. Those are probability tables only. Okay, when we are talking of probability, we don't talk of the exactly. Okay, we talk of the maybe or may not be kind of situation. Okay, so here also we are talking about the maybe or may not be type of situation only. So he has given two assumptions. See, all deaths are immediately replaced by births. So here, when we are talking of the machines or the components, all failures are immediately replaced by the other assets. Okay, other components. Okay, suppose the bulb has failed, we are immediately replacing the bulbs. There are no other entries or exits. So these are the two assumptions on which the mortality theorem clearly works. So what happens here is, after some time, see, when I have 1,000 bulbs in my organization, okay, so 50 bulbs have failed. Immediately, I have replaced the 50 bulbs. So at any instance of time, I have 1,000 bulbs, isn't it? So there is a stability in the death rates. There is a stability in the birth rate. So the constantly you have achieved an equilibrium, because the death rate is immediately replaced by the birth rate. They are all equal. Okay. So there is a stability in the organization. There is an equilibrium. This is what it is assumed. Suppose every law will have some assumptions. Why you have assumptions is to keep the law simple, basically. And then we will talk about, if I relax this law, how is it, this assumption, sorry, if I am going to relax this assumption, how is it affecting my law? Okay, this is what you think, right? Even in economics or physics, chemistry, any science, you have certain laws. Okay, you are trying to define something, you are trying to find out the connectivity between two variables. You always have certain assumptions. So given these assumptions, this will work out. That is what you'd say. Okay, so why? Because if there are intervening variables, then the law doesn't work out, isn't it? So here mortality theorem is given. I'll just read it out for you. A large population is subject to a given mortality law for a very long period of time. All deaths are immediately replaced by births, and there are no other entries or exits. These are the assumptions. Then the age distribution ultimately becomes stable, and that the number of deaths per unit time becomes constant, which is equal to the size of the total population divided by mean age of the death. Okay, so this you will understand it better when you see the numerical example. Okay, what he's saying is, the total, ultimately you reach an equilibrium. Ultimately the number of deaths per unit time becomes constant, means number of failures per unit time becomes constant. That unit time, it can be a day, can be a week, can be a month. Okay, so number of failures. So over the years, what happens is number of failures. So I know for sure that in a week maybe 20 bulbs fail. On an average, 20 bulbs fail. Okay, so on an average 20 doesn't mean that every time 20 bulbs only fail. It can be 25 sometimes, it can be 15 sometimes, quite possible. Okay, but I know for sure that on an average, I have to spend for 20 bulbs in a week. Okay, so that is what is reached in that equilibrium is reached in this mortality theorem. Okay, so you can see this example. Okay, I'll just read out this also. Group replacement of items that fail completely. And this group replacement of items will work out only for the components or assets which are of low value. Okay, say I have very big machinery. Okay, say I have a hospital. Okay, I have MRI machines which come at a very huge cost. Okay, MRI machines, some say 40 or 50 I have. Okay, so one machine is failed, that doesn't mean that I replace all the machines. Okay, that is not quite feasible for me. But here the example which he has taken is of light bulbs. Okay, so light bulbs is of lesser value. So if few bulbs also fail, I can take a decision of group replacement if it is really cost effective for me. Okay, we will see here. He is asking you to find out, is it feasible for you to take a group replacement decision? If yes, in which week, at how many intervals you have to take that group replacement decision? Okay, see here bulbs, they have certain life. Okay, so here you can see in the numerical, is it visible for everybody?
Yes.
Yes. Okay, so I'll just read this out for you. There are certain items light bulbs that either work or fail completely. So there is no midway. Like, it's not like it is either pass or fail. It will either work or it will fail. It is not like it is half working, half not working, or it is dim, nothing like that. No draw condition is there. Okay, it will either work or fail. In some cases, a system made up of a big number of similar low-cost items that are increasingly prone to failure with age. While replacing such failed items, always a setup cost will be there for replacement. You have to underline this. There is a setup cost. Means suppose the bulbs have failed, I need to call an electrician to replace those things. Okay. So electrician, suppose he's charging me some charges for fixing the problem. Like, these are not a setup costs. Okay. So I have to call an electrician, and he, to replace 5 bulbs also he's charging me same. For replacing 20 bulbs also he's charging me same. Okay. So these setup costs are constant irrespective of how many things you are getting him replaced. Say I have called a carpenter to do some petty work. Okay. To just fix the nails in my wall, to fix up some portrait, some pictures on my wall, suppose. So he's charging me say 300 for the visit. Okay. Even if I get him fixed 2 nails also, he's charging me 300. For getting 10 nails fixed also, he's charging me 200, 300. Isn't it? So the setup costs are same. Okay, setup costs are fixed. Okay, if I'm fixing 1,000 bulbs also, his my cost incurred is same. Even if I'm replacing 2 bulbs also, my cost is same. So these are fixed. The set setup cost is independent of the number of items to be replaced, and hence it is to be advantageous to replace entire group of items at the fixed intervals. So this is where your group replacement items will really work out. See, if I'm replacing 5 bulbs also, it costs me same. If I'm replacing 1,000 bulbs also, it costs me same. Okay. Because when I'm calling an electrician, I'm paying him for the time which he has given. Okay, it is same. Or it is assumed to be same. Or little different it will be, but not much. Okay. So in that case, is it beneficial for me to replace all the low cost items, or is it beneficial for me to replace only those items which have failed? This is what we have to decide now. Okay, individual replacement versus group replacement. Okay, such a policy is referred to as group replacement policy and found attractive when the value of an individual item is so less and the cost of keeping records of the age of the individual item is not justified. See, yesterday Harsha was asking me a doubt that does organization really have the time to do the uh, failure mode failure modes and effects analysis or not?
Yes, ma'am.
Do they really have time? So here also he is saying the same thing. Do we really have time to keep a track of the life of the bulb into consideration? They are so less in value, isn't it? So it is, they really don't have time to keep a track of individual item. So is it good that at regular intervals, okay, maybe every 3 months I get all the bulbs changed? Okay, is it cost effective for me or not? We are going to see in this numerical. Okay, so group replacement policy, here he has explained the numerical. Okay, for a certain type of light bulbs, 1,000 numbers from following mortality rates are given. Okay, mortality rates are given here. So for 1,000 bulbs, he has said that chances of a bulb failing in one week, at the end of 1 week, is 10%. Okay, chances that the bulb percentage failing by the end of the week. Okay, at the end of the 1 week, 10% of the bulbs have failed. At the end of the second week, 25% of the bulbs have failed. At the end of the third week, half the bulbs have failed. Okay, these are cumulative figures. Okay, are you getting the point? These are cumulative figures. Okay, so 1,000 means 10%. 10% of 1,000 comes to 100 bulbs. So 100 bulbs have failed in the first week. Then in the second week, 150 have failed, so the total has come to 250. Okay. After the end of the third week, totally from the first, second, third week put together, 500 bulbs have gone. After the end of the fourth week, 800 bulbs have gone. At the end of the fifth week, all the 100,000 bulbs have gone. Okay. So, what's the maximum life of the bulb here?
3 months.
How much?
3 months.
3 months, sir.
Can you repeat it?
What is the maximum life of the bulb?
I didn't get it, ma'am.
What is the maximum life of the bulb? Maximum life. See, after the end of the 1 week, 10% of the bulbs are failing. After the end of the 2 weeks, total 25% of the bulbs have failed. After the end of 3 weeks, 50% of the bulbs have failed. After the end of 4 weeks, 80% of the bulbs have failed. After the end of 5th week, all the 100% of the bulbs have failed. This is what is given. So I'm asking you, what is the maximum life of the bulb?
5 weeks, ma'am.
5 weeks, very good. Okay, so maximum life is 5 weeks. Now we have to decide here. He has given you further things that each bulb costs 10 rupees to replace. Okay, suppose few bulbs have failed, I need to replace it, I need to spend 10 rupees for each bulb. If bulbs were replaced at the same time in group, okay, in group I'm replacing it, all the 1,000 I'm replacing it, it would cost me only 4 rupees because I'm doing bulk purchases. Okay, so it is saving my cost. Huge saving is there. Then it is under this proposal to replace. So there is a proposal to replace all the bulbs at the fixed interval of time, whether or not the bulbs have burnt out. Also, and also it is to be continue replacing immediately burnt out bulbs. See here, when you're taking group replacement decision, that doesn't mean that suppose today I have replaced all the 1,000 bulbs. Okay, the bulbs life has started today. Okay, at the end of 1 week, say 100 bulbs have failed. Okay, before that, I need to replace those bulbs. Okay, then again, when I'm taking a group replacement decisions, I have to get it replaced all the bulbs also. Okay, that so at any instance of time, I should have 1,000 bulbs glowing in my organization. 1,000 bulbs. So that is the condition. Okay, did you understand? I'll share the thing. 1 minute. I'll share the whiteboard also. Okay, 1 minute. See, suppose at the end of 4th week, okay, so now I have bought the, at the 0th week, 0th day, I have bought the bulbs, 1,000 bulbs. Okay. At the end of 1st week, suppose 100 bulbs have failed. I replace those. Okay. Because every time I should have 1,000 bulbs in my organization. There shouldn't be like only 800 bulbs are there, 500 bulbs are there. It shouldn't be that case. Okay. Now at the end of 2nd week, suppose I have taken a decision that I'm going to replace all the bulbs at once. Even if they are not failed, also I'm going to replace. So I'm replacing all the 1,000 bulbs. Okay. But whichever I failed after that, also I will replace it. That doesn't mean that 1,000 I have changed, means that doesn't mean that after that some bulb fails, I'm not going to replace that. Okay. So this is what is given in the numerical. Now he is asking you, determine the time interval at which the bulbs should be replaced. This is the question. Okay. We have to find out after how many weeks I should go for a group replacement. After how many weeks I should go for a group replacement. Is the question clear? Yes?
I got it, ma'am. Yes.
Yeah. I believe both of you, Abhiram and Sri Harsha, are having the book and pens with them.
I do have. I do have.
Yes. Okay. So we'll start the numerical, right? So here, let us find out first probability. Okay, probability of the bulb failing after 1st week, 2nd week, 3rd week, 4th week, 5th week. Okay. So I'll just, you all have the numerical, or you can note down this. 10, 25, 50, 80 and 100. Okay. Yes. Let's share the whiteboard. Okay. So 1, 2, 3, 4, 5. 10%. Okay. 25% of the bulbs have failed. 50%, 80%, 100%. Isn't it? This is what is given. Okay. Now, a bulb failing in the first week, what is the chance? Isn't it 0.1? Or I will write down again 10, 25, 50, 80, 100. So first week, 10 have failed. 10% have the bulbs have failed. Second week, cumulative is 25, means 15 bulbs have failed. 15% of the bulbs have failed. Okay. Third week, 25% of bulbs have failed. Fourth week, 30% of bulbs have failed. Fifth week, 20% of the bulbs have failed. Are you getting the point here? See, first week, 10% of the bulbs have failed. Second week, 15% of the bulbs have failed. Third week, 25% of the bulbs have failed. Fourth week, 30% of the bulbs have failed. Fifth week, 20% of the bulbs have failed. Okay, cumulative, it is coming to how much? 100, isn't it? Yes? Please, I need a
It's
response.
100. Yeah,
Yeah.
it's 100.
Okay, 100. So now probabilities are first week, the chances of a bulb failing is 0.1, isn't it?
Yes.
Second week, the chances of bulb failing is 0.15. Third week, the chances of bulb failing is 0.25. Fourth week, the chances of bulb failing is 0.3. Chances of bulb failing in fifth week is 0.2. Together, it is 1. Okay, the sum of the probabilities is always 1. Okay, so probabilities that bulb will fail in sixth week is 0 because all the maximum life is 5 weeks. Bulb won't survive beyond 5 weeks. Okay, so chances of bulb failing in sixth week is 0. It is an uncertain event. Is that clear? Is the probabilities clear?
Yes, ma'am.
So I'll write down again probabilities of failing in first, second, third, fourth, fifth weeks are 0.1, 0.15, 0.25, 0.3, 0.2.
3.2.
Yeah, 0.2. Okay. Is this clear till here?
It's clear, ma'am.
Okay. Now, I'll take you to here. Okay. Then further in the last line, if you see, he defines NI. NI, he says that number of replacements made at the end of the ith week. Number of replacements. How many bulbs are you replacing? When are you replacing the bulb? When they fail, isn't it? Okay. See here, last but one sentence, he says that it is assumed that bulbs that fail during a week are replaced just before the end of that week. Okay, so that we have all the 1,000 bulbs at the end of the at the beginning of the next week. Okay, at the end, say Saturday, Sunday, you are not working, so you will check on Friday how many bulbs have failed. You are replacing it on Saturday, so that Monday you are ready with all the 1,000 bulbs again, isn't it? Is it clear?
Yeah,
So
ma'am.
NI is nothing but the number of replacements made at the end of the ith week. Okay. C means N, you will have N naught, you will have N naught. N naught means number of replacements, number of bulbs you have bought at 0 at the time. N1 means number of bulbs you have replaced at the end of first week. Number of bulbs you have replaced at the end of second week. Number of bulbs you have replaced at the end of third week, fourth week, fifth week. Is that clear? NI means number of bulbs you are replacing at the end of ith week. Okay. 0th week, 1th week, first week, second week, third week, fourth week, fifth week. Okay. So we will find out all these values. Okay. In the next page, he has given, if you have study material, you can go to the next page. Here it is a printing mistake. This question mark shouldn't be there. Okay, instead of question mark, what it will be, I'll tell you. Okay, so this is a printing mistake. Sorry for that. So you can correct that in your books. Okay, so yeah, can you see
Is
here?
it divide, ma'am?
Yeah, he has calculated N0, N1, N2, N3, N4, N5, N6, N7, isn't it? Yes.
Yes, ma'am.
Yeah. So we'll calculate N0, N1, N2, N3, N4, N5, N6 together. Okay. I'll go to the page whiteboard again. N0 means number of bulbs replaced now, 1000, isn't it? Today I have bought 100,000 bulbs for my organization. N0, 1000. Okay. At the end of N1, okay, at the end of N1, see, we have written the probabilities of failure at the end of first week, second week, third week, fourth week, fifth week. What is the probability of failure at the end of first week?
100?
It is 0.1, isn't it?
Yeah, 0.1.
Yeah. So means there is a chance that 0.1%, 0.1 of 1000 will fail. So I need to replace them, isn't it?
Yes.
Yeah. So N1 will become 100. Did you understand how you get 100?
Yes, ma'am.
Yeah. So N1 is 100. What is N1? 100. See, I'll try to explain it again. See here. The first week, today I had bought 1000 bulbs. At the end of first week, means next Sunday, I have to replace 100 bulbs, isn't it? Because they have failed. Is that clear?
Yes, ma'am.
Yes. Now at the end of before beginning of the second week, what happens? I have 900 old bulbs, 100 new bulbs, isn't it?
Yes, ma'am.
Yes. So N2 is equal to, see,
0.15 into 1000.
yeah, I'll just get you to this here. See, 1000 bulbs, the chances of failing in the second week is 0.15, isn't it?
Yes.
1000 bulbs, the chances of failing for the second week, the life of the bulb is 2 weeks, is 0.15. Plus, but you have 100 bulbs which are new. For them, this is the first week, isn't it? Are you getting the point? See, for the 1000 bulbs, okay, for some bulbs, it is the second week. For some bulbs, for 100 bulbs, it is the first week. So chances of 100 failing in the first week is 0.1, isn't it?
Yes, ma'am.
Yes. So how much do you get? 1000 into 0.15 is how much? 150, isn't it? 1000 into 0.15 is how much?
150.
150. 100 into 0.1 is how much? 10. Isn't it 10? Yes. So there are 160 bulbs which are to be replaced at the end of second week. See, for the first week, the calculations are simple. For all the 1000 bulbs, it is the 0.1 probability, you just multiply it. But at the end of second week, what happens is, for the bulbs which are brought here, it is second week. So 0.15 probability has to be taken. But bulbs which are bought here, for them, it is the first week. So 0.1 probability you have to take. So the total number of replacements which happen at the end of second week is 160. Is it clear? Yes.
Yes, ma'am.
Yes. Now shall we go to the third week?
Okay.
N3, 1000 multiplied by, what is the third week's probability?
0.25.
0.25. Now the 100 bulbs which we bought for them, isn't it the second week?
Yes, ma'am.
Yes. And for the 160 bulbs which we replaced, isn't it the first week?
Yes, ma'am.
Yes. See here, these are the old bulbs. These are the weeks bulbs which we bought at the N1. These are the bulbs which we bought at N2, isn't it? So the old bulbs, first week bulbs, second week bulbs, for all we have to find out, because different bulbs will have different ages. Okay. For this, the old bulbs, we have to take the third week's probability. For the 100 bulbs, we have to take the second week's probability. For the new bulbs, relatively the newest bulbs, we have to take the 1 week's probability. Okay. So we have to find out N3. I will take you to here. So instead of these question marks, you have to replace it with multiplication. Okay. So 1000 multiplied by 0.25 plus 100 multiplied by 0.15 plus 160 multiplied by 0.1. Is that clear? 1000 bulbs are the oldest bulbs and not. For them, we have to take the third week's probability. For 100 bulbs, we have to take the second week's probability. And for the 160 bulbs, we have to take the 1 week's probability. Okay. So 1000 into 0.15 plus 100 into 0.15 plus 160 into 0.1. Is it clear? Is it clear?
Yes, ma'am.
Yeah. So how many bulbs are replaced at the end of third week?
It is 150 plus 15.
Here there is on the screen. Are you able to see? It is 250. See, 1000 into 0.25 is 250, isn't it? Plus 100 into 0.15 is how much? 15. Plus 160 into 0.1 is 16. So how much it is coming to?
Two 281.
281. So can you see number of bulbs which are replaced have increased. At the end of first week, only 100 bulbs were replaced. At the end of second week, 160 bulbs are replaced. At the end of third week, 281 bulbs are replaced. Can you tell me for fourth week, N4? See, for the 1000 bulbs, the old bulbs, it is the fourth week. So fourth week probability is 0.3, isn't it? Yes, in
Yes,
that
yes.
probability, yes. Plus 100 bulbs, which we replaced at the end of first week. For them, it is the third week. Third week's probability is how much? 0.25. Plus 160 bulbs, it is the second week for them. And lastly, 281 was there, no? For 281 bulbs, which we have replaced it very last week, for them, this is the first week. Okay, so this is the number of failures in the fourth week. Are you getting the point? For the old bulbs, it is the fourth week. For the 100 bulbs, it is the third week. For 160 bulbs, it is the second week. For 281 bulbs, it is the first week. So we have to take the respective probability. See, we have different bulbs at different ages. That's why we have to take the different probabilities. Okay. So 281 bulbs, they are the new bulbs. So their chances of failing are very less, 0.1. The old bulbs, that is the 1000 bulbs, the chances of failure are 0.3. For the next 100 bulbs, the chances of failure are 0.25. For 160 bulbs, the chances of failure are 0.15. Okay. So how much is it? 1000 into 0.3 is 300. 100
300
into
plus
0.25
25.
is 25
25 plus
plus,
24 plus 28.
very good, 28.1. Yeah, how much is it coming to?
377.1.
Very good. Okay. So I'll go to this. Is it correct? Have you got 377 only?
377.1.
Yeah. Yes, very good. Okay, so you understood how many bulbs are failing. You can calculate it, isn't it?
Yes, ma'am.
Yes. Now I'll go to this because only 10-15 minutes are left. We will go to this table. This table also, there are some mistakes in it. Okay, if you can see the last table, 1.2 table, I will explain it. I have made a corrections in the material, the physical copy of the material. I have made the corrections and I have taken a screenshot of it. I'll be sharing that. Please, you make a note of that. Okay. Yeah. Are you able to see this? Sorry. Yeah, are you able to see this?
Yes, ma'am.
Yeah. Now here, the thing is, okay. So earlier we have found out how many bulbs are failing, isn't it? Okay. You can see here, right? Number of bulbs failing, they have increased from 100, they have increased to 160, then increased to 281, then increased to 377. Okay. So then again it has decreased. It is going on decreasing, isn't it? N5, N6, N7. Can you see the decrease? 350, 230, 28. Again it has increased a little. Okay. So he has done the calculation of group replacement for 4 weeks. Only for 4 weeks he has shown the calculations. Now we have to decide at the end of how many weeks are we going for group replacement. This is what is asked in the question. Okay. At the end of second week or at the end of third week or at the end of fourth week. At how much week are we going to group replace the bulbs? Okay. So the point here is, if I'm going to replace individual bulbs, it costs me 10 rupees. But I'm going to replace all the bulbs, it costs me 4 rupees each. Okay, so this is the logic. And we'll go ahead with the table, which I have taken a screenshot of. You can actually write down this because there is a slight printing mistake there. You can see I have made a correction and I have taken a screenshot of it. Okay, you can copy this instead. Okay. Now, you have all the numbers with you, right? So first, at the end of first week, if I'm going to replace individual bulbs, how many bulbs have failed at the end of first week? At the end of first week, N1 we have calculated, isn't it? N1, N2, N3, N4 we have calculated. At the end
Yeah,
of
yeah.
first week, how many
100,
bulbs have
ma'am.
failed?
100,
100, very good. If I'm replacing all the 100 bulbs at 10 rupees each, how much does it cost me?
400.
10 rupees. See, when I'm
No,
not
no.
going for group replacement, each bulb costs me 10 rupees. Okay.
Okay,
So
10
now,
into 100,000.
10. Very good. At the end of second week, how many bulbs have failed? N2. You can check
160.
N2. 160. 160 into 10 will cost me how much?
1600.
Right. At the end of third week, how many bulbs have failed?
281.
Yeah. So how much does it cost me?
2810.
Yes. At the end of fourth week, how many bulbs have failed?
377.
Yeah. So how much does it cost me?
3770.
Very good. So is this column clear?
Yes, ma'am.
Yeah, when I'm going for individual replacement, each replacement will cost me
10
10
rupees.
rupees. So these are the costs. Okay. Now we have to compare these costs vis-a-vis group replacement cost. Okay, and wherever it is economical for me, we will go for that group replacement. Okay. Now, if I'm going for group replacement, the logic is I'm replacing all the 1,000 bulbs, isn't it? 1,000 into 4. How much does it cost me?
4,000 plus
Yeah,
1,000.
4,000 plus
5,000.
why it is 1,000? Because at the end of week, see, even though I have spent 4 rupees to replace all the 1,000 bulbs, so it costed me 4,000 plus 100 bulbs have failed, no? That I have bought it at 10 rupees each. Okay, so how much does it cost me?
5,000.
Total 5,000. Okay, so at N0 at 0th time, I have spent 4,000 rupees. At the end of first week, I have spent 1,000 rupees. So total cost is 5,000. Okay, is that clear?
So we are counting the 0th week also, no?
Yes. No, here group replacement, here what we are doing is we are finding out the total cost incurred. We are going on accumulating the cost and then we'll find out the average cost. Okay. Did you
Okay.
understand? See, at the 0th time, how much did we spend to replace all the 1,000 bulbs? 4,000.
4,000.
Yeah. And at the end of first week, how many bulbs had failed?
100.
100. So for 100, we replaced it at 10 rupees, no?
Yes, we bought it individually, right?
No, 100. See, when we are going for 1,000 only, it will cost us 4 rupees. If we are going
Okay, okay,
repair
okay.
of 100, 160, it will cost us
Yeah,
10 rupees.
yeah,
Yeah.
yes.
So for replacing the bulbs, how much did we incur? 1,000, isn't it?
1,000, yes.
So how much is the total cost? 5,000.
5,000.
Till the end of first week, we have spent 5,000 rupees, isn't it?
Yes.
Yes. Now, till the end of second week, how much did we spend? 5,000 which we spent in the first week plus
Second
160
week,
bulbs, didn't
160.
we?
Yeah.
Second week 1,600, isn't it?
Yes.
So how much is the total cost spent till the end
5,000
of
plus
second week?
1,600.
How much is the
6,000.
cost?
6,600.
Yeah. Again, at the end of third week, didn't we spend 6,600 plus 28, 2,810?
Yes.
Yes. So till the end of third week, we have spent 9,410. Till the end of fourth week, how much did we spend?
13,180.
Very good. Is the total cost clear?
Yes.
Yes. Is the individual cost of replacement clear? First column, second column, is it clear?
Yes, clear.
Then in the final column, see, please make this correction. This 6,600 is not given in the study material. Please make the correction. Okay. Otherwise, you will get confused. Okay. Now, average cost per week is 5,000 divided by 1 is 5,000, isn't it? Yes. In the first week, we have spent 5,000. How many weeks have passed? 1 week. So 5,000 by 1 is 5,000, isn't it? Yes. Till the end of second week, we have spent altogether 6,600. So on an average, in every week, how much did we spend? 6,600 divided by 2.
Why 2, ma'am?
See,
Second one. Is it same?
yeah, I'll come again. Till the end of second week, how much did you spend total?
6,600.
Means on an average, every week, how much did you spend?
Okay, 3,300 per week.
Is it clear? Yeah,
Yeah.
3,300 per week. Yeah, at the end of third week, how much did we spend in total?
9,410.
Very good. So on an average per week, how much did we spend?
3,136.
Yes. Is it clear?
Yes.
Yes. Till the end of fourth week, how much did we spend in total?
13,180.
Yeah. On an average per week, how much did we spend?
3,295.
Yeah. Is it clear?
Yes.
Yes. Now, at what interval should we go for the group replacement? We will decide now. Comparing the first column and the last column. Okay. See, if you see the first week, if you see the second week, 1,600, isn't it lesser than 5,000? You have to compare the cost of individual replacement with the average cost. Okay. So isn't 1,600 lesser than 5,000?
Lesser.
Yeah. 2,810, isn't it lesser than 3,300? See,
Yes,
average
lesser
cost you
than.
should see of the previous week. Okay. Cost of individual replacement you have to see of this week. Third week versus second week you have to see. Okay. So, 1 minute. You have written down this values, is it 1,000, 1,600? Or I'll go to the whiteboard. Better go to whiteboard. Yeah, whiteboard. Here it is. Okay. I'll please write down these numbers. I have it with me in the book. Okay. 1,000, 1,600. Cost of individual replacement. 2,810. 3,770. 5,000. These are the average cost, isn't it?
Exactly. Yes.
3,295, isn't it? Yeah, these are the numbers, right? Okay, now I have to see. See, this 1600 is lesser than 5,000. 2810 is lesser than 3,300. But here, if you see 3,770, isn't it greater?
Yes.
Then
3,700 is
means,
greater.
yeah, means individual replacement is costing me more than the group replacement than the average
Fourth
cost.
week.
So at the end of third week, I should go for group replacement. This is how we decide. Okay, are you getting the point?
Yeah,
At
yeah,
the
yes,
end
ma'am.
of third week, we should go for group replacement. Whenever the individual cost is more than the average cost, we should decide that we should go for the group replacement. Okay, is the numerical clear?
It's clear, ma'am. Clear.
Okay, so I'll take you to this page where the solution is
Do
written. Yeah,
uh
the cost of
in
individual replacement in fourth week is greater than the average cost for 3 weeks. Therefore, the optimal replacement decision is to replace all the bulbs at the end of every 3 weeks. Okay. Otherwise, the average cost from the fourth week onwards will start increasing. Can you see here? Average cost from the fourth week, again, it is increasing. See, average cost has decreased, then it started increasing, isn't it? From 3,136, it became 3,295.
yes, yes.
Yes. So at the point where it is the average cost is least, we should decide that we should go for group replacement. Okay. So at the end of 3 weeks, 3 week gets over, you replace all the bulbs again, irrespective of whether they have failed or not. Is that clear?
Yes, ma'am.
Yes, and rest of the things in seventh unit you can go through. These are all the different concepts of replacements are mentioned there. Okay, this was the only numerical which was there in this unit. So I thought I will take up that in today's class. Okay, so is the numerical clear to everybody?
Yes, ma'am. It's clear.
Yeah. Okay, so we'll meet in the next week. Okay, with the other concepts. Thank you so much. Have a great week ahead to everybody.
Thank you so much.
Okay. Thank you.